All right, we're done with the starter. Hopefully you've got that all saved. And so for this next little piece, I'd like you to open up, I think, a drawing in Seesaw. I'll give you just a moment to do that. And what we're going to do is we're going to write some reactions. We're going to write 3 different reactions. And so I just really briefly wanted to go over with you again our 5-step process that we write the reactants, then we write the products. We check for diatomic elements, balance the product, and then balance the entire reaction. This is just our first 5 steps in this prediction process. And so I want to make sure we're well grounded here in these first 5 steps before we move on into to new things. All right. So the first reaction that I'm going to give you, we're going to switch over here to Apple TV and some notes. And this first one, hopefully you're over into Seesaw at this point. And we're going to start out with our first reaction. This one is going to be nitrogen and carbon. Those are the 2 we're going to put together. All right? Nitrogen and carbon, so if you're ready, go ahead and do it. All right, I'm going to start in here. At any time that you want to work on it, you could pause the video, you could work on it, and then catch back up. All right, or let me catch up with you. All right, so here we go. Nitrogen plus carbon. That's the first step. Write the reactants. I'm going to put the arrow in because I'm going to write the product. Now it matters which one is furthest to the left. Well, carbon and nitrogen are right next to each other in the periodic table, but carbon is furthest to the left, so I'm going to do that. Carbon and nitrogen. All right. Now I have to go back. I have to check for diatomic elements. And on that left side, nitrogen is traveling by itself, and it is diatomic, so I need a 2. Carbon is not diatomic, so I don't need a 2. On the right side, the nitrogen, it's a diatomic element, but it's already traveling with a friend, so I don't need any extra numbers. Step 4, I'm going to balance the molecules. So in this case, remember, carbon is +4, nitrogen -3. So when we go over and check out periodic table, remember that these are -1, -2, -3, +4, okay, while we're checking out those charges. All right. Head back over here. And so when we switch those numbers, there will be a 3 behind the carbon and a 4 behind the nitrogen. And I'm going to remove these numbers up on top because we don't need those anymore. All right, step 3, check for diatomics. We've done that. Step 4, balance the product. So now step 5 is going to be balance the entire equation. So we have 3 carbons on the left and on the right. We're going to need 3 on the left, so we'll put a 3 there. We have 4 nitrogens on the right, but only 2 on the left, so we could use a 2 over there, and then a 1 over here. So 2, 3, 1 will balance that reaction. All right, the second one for today, I'm going to switch this up a little bit, and I'm going to tell you that we are going to react iron, oh boy, a transition, iron 3 with oxygen. Those are the ones we're going to put together. All right, so here we go. Iron 3. So that is Fe, if you check out the periodic table, plus oxygen. And I'm just going to move a little quicker. So it is Fe and O. I put those together. Iron is to the left of oxygen, so it comes first. Oxygen is diatomic. It needs a 2, but not on the other side because it's traveling with iron. balancing the iron and the oxygen. So the iron I said was +3 right there. So I know the iron is +3, the oxide is -2. So I switch those numbers, Fe2O3. And now I just have to balance the entire reaction. So those oxygens, I have 2 on the left, 3 on the right. So I'm headed for 6. So I've got 3 times 2 is 6. And 2 times those 3 oxygens is 6. So I now have 4 irons on that side, so I need a 4 over there as well. And that finishes that one. The coefficients are 4, 3, and 2. And that's our practice today for writing chemical reactions and making some predictions.